Integrated Pest Management, or IPM, is a pest control guide recommended by UW Extension. In this session, we'll take a detailed look at IPM and how to apply it to control pests in your own home or garden.
Most IPM definitions are fairly technical and are intended for commercial growers and farmers, but we'll simplify it a bit for our purposes. IPM is a comprehensive approach to pest control that uses multiple tactics to reduce damaging pest outbreaks and to reduce risks to human health and the environment. Let's break that statement down into a few pieces. First of all, IPM is a comprehensive approach, which means it tries to take into account the big picture, such as economic or aesthetic value of the plant or crop, as well as the potential of the pest to cause significant damage, so you can make an informed decision about what tactics to use to control that pest. IPM recognizes that there are a variety of tools or tactics available to control pests and helps you organize your priorities to choose the best one for your circumstances. We'll talk specifically about the pest control tools that are available later on, but in general there are 4 categories of biological, cultural, mechanical, and chemical control. For example, if you have a pest problem in a high-traffic area, then risks to human health are going to be higher, and you'll want to consider pest control tools, like cultural or mechanical methods, that pose less risk to humans than chemicals do. Also, our goal is reducing pest outbreaks, not necessarily eliminating them. The cost to human and environmental health of complete eradication of the pest may be too high. You may be sick and tired of those box elder bugs in your yard and house every fall, but total control may just not be possible. Identifying the level of pest damage that you can live with is an essential part of IPM. Tolerance of some pests is a lot easier on the environment than the chemical blitzkrieg that would be necessary to eliminate every bug.
Now that you have a general idea of IPM, let's take a closer look at each of the individual components that go into identifying your priorities and fleshing out this decision-making process. This graphic outlines the building blocks of IPM. As you can see, we've built this graphic as a pyramid, and like any pyramid, a strong foundation is critical. The foundation of the IPM process is knowledge. The more you know, the better decision you will be able to make. You need to know about your pest life cycle, behavior, how its population is going to grow. You also need to know about the host, what the value and growth habit of that plant or crop are, and how both the host and pest fit into the larger ecosystem of your garden or your field. We'll discuss the individual components in just a moment. The point of all this knowledge is to make an informed decision. The central block in our pyramid lists our decision-making aids, tools like proper pest identification, pest and environment monitoring, temperature, humidity, and so forth, and priorities including economic injury levels and action thresholds, so you know how much damage your plants can take before you need to take action. Finally, on the top of the pyramid are the pest management tactics: biological, cultural, mechanical, and chemical controls. These are the tools that you'll actually use to control the pest, and I can't emphasize enough, which tools or tool you choose to use will depend on the knowledge and priorities specific to your situation. As a quick aside here, I want to compare the building blocks of IPM with the building blocks of organic pest control. If you're thinking that you want to grow organically and follow organic methods of pest control, and maybe you don't need to understand this integrated pest management process, I'd like to point out to you that IPM and organic pest control are almost exactly the same. In fact, there's just one difference. Chemical pest controls in organic systems are limited to those that are certified as organic controls. That means that they are derived from natural products, and no synthetic chemicals can be used. Organic pest control still relies on choosing from a range of tactics based on the knowledge and priorities specific to your situation. Effective organic pest control and integrated pest management both require accurate information. The foundation of IPM is knowledge. Knowledge of the pest's life cycle, behavior, any seasonal cycles, population growth, and their interactions with their host and environment. In pest management, not understanding as much as you can about your particular control situation will make your efforts less effective. First of all, you need to know as much as possible about the pest itself. For example, how does it reproduce? If it's a weed, is it annual, biennial, or perennial? Annuals will come back from seed each year. Biennial and perennial weeds need to be treated differently. because they may have vegetative storage structures that can help them survive weeding or even push through a thick layer of mulch. While some insects may have just a single generation each year to contend with, others are fertile breeders and can hatch a whole new generation every 2 to 3 weeks during the warm summer weather. Some plant diseases may spread through the air, while others spread by water, and still others may be harbored in the soil. Next, it's important to understand the growth characteristics and habit of the pest. Will the weed, insect, or disease be aggressive and take over an area quickly once it appears? Where does the pest come from, and where is it when it's not wreaking havoc in your lawn and garden? How far do weed seeds travel? Do insects overwinter here in Wisconsin, or are they blown in on a warm southern winds as the season progresses? Some diseases surviving a dormant stage in the soil, but in other cases, there may be an alternate plant host where the disease can survive and from which it can infect your garden. Other items to consider include the pest's rate of growth and population size. Again, does it have just one generation per year? In that case, there's likely to be a set number of eggs that hatch and mature into adulthood. That can be easier to deal with than another insect pest that produces many generations in just one season. Understanding the pest population cycle can help you decide whether or not it's worth attempting to control, and when is the best time to apply your controls. The final piece of the information puzzle is the interaction that the pest has with the host. Some weeds can actively inhibit the growth of nearby plants. Allelopathy is what gives things like garlic mustard and black walnut an edge. They produce toxins that help them outcompete nearby vegetation. Plants may produce galls in response to insect feeding or egg laying in an attempt to contain them to a small area of the leaf or stem. Certain insects may also transmit plant diseases, but since they can spread viruses from plant to plant when they feed, it may be important to control them anyway. And in some cases, the plant itself will try to isolate a disease into one section of the leaf or stem, which means that removing that particular part of the plant may slow the spread of your problem. Once you know as much as you can about the pest, you can use that information to make an informed decision. The central section of our IPM pyramid describes the decision-making tools that form the core of integrated pest management. These aids will help you link your knowledge of the pest with the priorities and special needs of your situation, and then choose the methods of control that are most appropriate. The first decision-making tool is directly related to your knowledge about the pest. It's proper pest identification. Unless you accurately identify the pest, chances are slim that your pest control efforts are going to work. All the knowledge in the world won't help you if it's knowledge that doesn't pertain to your situation. These are pictures of two very similar-looking weeds. The first is wild buckwheat, and the second is hedge bindweed. The buckwheat is an annual weed that grows from seed every spring. The hedge bindweed, on the other hand, is a perennial weed that grows back each year from a root system that can extend underground up to 40 feet. Control methods for each will be very different. At times I've had various homeowners describe fungal problems they were having with their plants. Sometimes these really were a fungus like powdery mildew. In other cases, closer inspection showed that they were actually mealybugs, an insect that produces what often looks like fuzzy mold. Even worse, I recently had a colleague confess to me that in his first job at a greenhouse he was very enthusiastic about keeping the plants clean of bugs. Unfortunately, his boss wasn't very happy to find out that he'd been systematically squishing one of their best biological pest controls. Although these little guys look a lot like giant mealybugs, they're actually a beetle larva that are often released into greenhouses on purpose because they're voracious feeders and their favorite food is the mealybug itself. Because pest identification is such a critical part of pest management, it's always a good idea to get a second opinion if you're unsure. This is particularly true of plant diseases. There are a lot of diseases that look alike even to the trained eye, and sometimes things that aren't diseases may easily be mistaken for them. This first image is a virus on a cucumber. The distorted leaves and discoloration are fairly typical of a viral infection. The second image is of a cyclamen plant, and it also shows discoloration and distorted growth. However, there's no disease on this plant. Instead, what you see is phytotoxicity. A pesticide used to kill insects also caused damage to the plant tissue. There's not a lot the average homeowner can do about plant viruses. The best response is to just get rid of the plant and make sure to carefully wash all tools and pots that came in contact with it. Happily, the plant with pesticide injury will eventually grow out of it. Once you are certain you know what the pest is, the next step is to assess the severity of the problem. Both traps and visual inspection can be used to check population levels. Greenhouse managers use yellow sticky cards to trap and count numbers of flying insects, and you've probably seen emerald ash borer traps like these set up throughout the state as entomologists monitor the spread of that invasive pest. Monitor and be on the lookout for pests frequently. The best time to respond to a pest outbreak is when it's small and easily manageable. Regular checks will help you catch things early. Keep records of what you see so you can recognize trends and anticipate when the pest population is going to get out of hand. Look for signs of the pest as well as symptoms. Signs are evidence of the pest itself, either the insect, weed, or disease, or eggs. Symptoms are evidence, such as distorted growth, that the pest has been there, although it may no longer be present. In addition to tracking the pest, environmental monitoring can also be a useful tool. Air and soil temperature are directly related to pest development and growth. For example, crabgrass doesn't germinate until the soil temperature is between 55 and 60 degrees Fahrenheit. This is important if you want to use a pre-emergent herbicide to prevent germination. If you put the herbicide on too early, it will break down in the soil and not be effective when the temperature is warm enough for the seeds to sprout. On the other hand, if it's applied too late, the seeds will have already sprouted and be unaffected by the pesticide. Powdery mildew on lilac will develop when the air temperature is between 60 and 80 degrees, but only if the relative humidity of the air is also high. So it's only necessary to do preventive fungicide sprays when the weather forecast is favorable for the disease. Knowing the environmental conditions and the pest's behavior can help us predict when outbreaks are likely to occur and not waste time and resources on pest controls that aren't needed. Commercial growers and farmers regularly use environmental conditions and models to predict pest outbreaks and plant injury. Phenological indicators, such as remembering to treat crabgrass when the forsythia blooms, are useful, though not exact. More precise calculations based on temperature, such as growing degree days, can very accurately predict pest development and help farmers know when to apply pest controls so they'll do the most good and least harm to the environment, as well as their pocketbook. Pest controls, as well as the labor needed to apply them, can be costly expenditures of time and money. In a perfect world, our plants would grow beautifully on their own without any interventions on our part. However, since pests are a part of plant cultivation, it's important to understand when is the best time to intervene. Commercial growers use decision-making aids including economic injury levels and action thresholds to help them decide. Since they're hoping to make a profit from their crop, it's a little easier for them to quantify the value of the plants and the losses that weed competition or disease or pest injury will cause. Generally, action thresholds, the point at which you need to control the pest, will be higher for home vegetable growers because they aren't trying to sell a perfect fruit, and a few blotches or blemishes won't matter as much when you're eating or canning your produce yourself. On the other hand, thresholds for ornamental plants around the home may well be lower than for vegetable crops because the aesthetic value of a prize rosebush or a dwarf conifer is that much greater. You may not use all of these tools for every situation, but the point of these decision-making tools is at the top of our pyramid. What controls are you going to use to manage your pest? We break down our control options into 4 basic categories: biological, cultural, mechanical, and chemical controls. Let's look at some examples of each. Biological controls represent a natural balance. They're the natural enemies that keep pests in check in a well-balanced ecosystem. Natural enemies include predators, like this lacewing larva you see devouring an aphid, pathogens, and parasitoids. You can sometimes find these for sale at garden centers and in mail-order catalogs. However, effective biological control can also be accomplished by simply encouraging your local population of natural enemies to hang out in your flower and vegetable garden. In order to do this, you have to make your garden a safe place for them. Usually, this will mean no chemical pest controls or only using selective pesticides that will be very specific in the organisms that they target, An ant and wasp spray will get rid of your picnic nuisances and those annoying yellow jackets, but will also be toxic to any parasitoid and predatory wasps that may be feeding on the aphids and caterpillars in your garden, to say nothing of the honeybees. You can also encourage natural enemies to visit your garden by providing them with alternate food sources. The minute pirate bug, Aureus insidiosus, loves to eat thrips, but they also appreciate a snack of fresh pollen, so plant a few marigolds and you can make your vegetable garden a little more appealing to them. One thing to recognize about biological controls is that they are not immediate. They're also not 100% effective. Most natural enemies will not completely eradicate their prey species. If they did, their own populations would crash. And finally, as I mentioned before, you need to consider compatibility with chemical controls as well as the environment, and even other beneficials when using biological control. Having a few praying mantises around the garden may seem really cool, but they tend to be generalist predators and eat anything they can get their mandibles on, whether a honeybee or a cabbage looper. The next category of controls, cultural methods, may be a little easier and more practical for the average gardener. These include ways to encourage your landscape's ability to defend itself against pests. They emphasize prevention of pest outbreaks by first of all promoting plant health. In general, healthy plants are better able to tolerate or withstand pests and diseases. Feed your plants well to prevent nutrient deficiencies and stress. However, bear in mind that too much feeding, and in particular too much nitrogen, leads to lush, succulent growth, something that aphids love. So plants that have been overfed with nitrogen are more vulnerable to aphid infestations. In contrast, spider mites particularly love stressed out plants, and often become a problem in dry years or when plants don't receive the right amount of water. Many fungal diseases can be prevented by improving airflow in the garden. Leaves of plants that are crowded close together remain wet longer, and diseases that need water in order to infect them have a better chance of surviving. Also, keeping your turf cut at the proper height can encourage it to grow thick and full and crowd out weeds that are trying to gain a foothold. It might help to look at pests as a symptom of other problems within the ecosystem of the garden. A healthy and diverse system should have natural checks and controls for pests.
You can prevent many disease problems by choosing resistant plant varieties. Seed catalogs and garden centers will show you which cultivars have been selected by breeders to be less susceptible to common fungal and bacterial pathogens. This defiant tomato, for example, has been bred for resistance to late blight. Planting it in your yard will reduce the risk that that's going to be a problem for you and impact your ultimate yield of tomatoes. In addition to keeping your plants and landscape healthy, you can also designate specific trap plants. Although whiteflies like tomatoes, they love eggplants even more. A few spare eggplants at the end of a row can keep the whiteflies happy and out of your better boy. Those same marigolds that provided pollen for your beneficials can be used to lure other insects that like pollen away from more valuable plants. These plants are also good places to start monitoring for pests, as they are likely to appear there first.
A thick layer of mulch can keep weed seeds from germinating, although it won't do much to prevent perennial weeds from poking their ugly heads.
Other cultural controls, such as floating row covers and nets, keep birds out of fruit trees and strawberry beds. Fences also prevent rabbits and woodchucks from ravaging the vegetable garden. We already use insect screens on our windows and plug up holes to keep small rodents out of our homes. Both of these are much easier tasks than chasing flies or baiting traps and then disposing of dead mice.
We can think of cultural controls as practical, hands-on methods for preventing pest outbreaks. Mechanical controls are the simple physical removal of pests and infested materials. Probably the mechanical method you are most familiar with is hoeing or cultivating the soil to root up weeds. You can also take it a step further and remove infested plant material by selectively pruning, or in severe instances, digging up and discarding entire plants. Finally, the last category of pest controls includes the chemical controls or pesticides. Remember that some pesticides can be used in organic cultivation. There are a lot of advantages to chemical controls. Many have a quick knockdown for fast and effective results, and they also require a lot less labor and forethought than most cultural, mechanical, and biological controls. Price will vary by product, but there is also a human and environmental cost to consider. We'll go into specific ways to reduce these costs in another section. But briefly, chemicals need to be handled with care however they are stored, used, and while they're active in your garden. Pesticides or chemical pest controls are available to help manage weeds, insect and diseases, as well as other pests including rodents, birds, and fish. Which pest control method you choose, whether chemical, cultural, biological, mechanical, or a combination of all four, will depend on the priorities you set for your specific situation and the knowledge you have about the pest and your garden ecosystem. Most IPM programs are designed with commercial production in mind, but the same principles apply for homeowners. We all consider the available tools and our personal priorities when we make decisions.
To finish up, I'd like to share an example from my own home. In this case, the pests I had to deal with were wasps. Now, they weren't in the garden, they were actually inside my house. This wasn't just the occasional wasp coming in through an open door or ripped screen, it was a recurring problem in the upstairs bedrooms. The wasps I was seeing were typical yellow and brown mud daubers. These are solitary wasps, but each female can tend several nests in a small area. The ones I was seeing were probably newly emerged adults, and I knew I was going to have to find their nests in order to get rid of them. Once I had identified the pest, the next thing to do was to make some observations, look around and figure out the extent of the problem and locate the source. I found it fairly quickly. A number of wasps had begun to build nests in my attic, and they were finding their way down into the house itself. While this wasn't really an economic or aesthetic problem, the consequences for not taking care of it were that someone was going to get stung. I don't mind wasps outside. Many of them are predators and help keep other pests in check. However, I wanted a solution that would remove the wasps from the house and keep them from coming back inside. The strategy I chose to use was a combination of 3 different controls. Since my attic is an out-of-the-way space and not often used, I felt that the risk of pesticide exposure would be low, so I used a chemical spray on the nests and any adult wasps that were hanging around. I didn't think biological controls were right for my situation, because I didn't have time to wait for them to take effect. I wanted the quick knockdown I would get from a chemical pesticide. I also covered the vent and fan openings with screens to prevent any more wasps coming in and making themselves at home. Finally, because any wasps that were immature or pupating might be protected inside the nests and unharmed by the pesticide, I went along the inside of the roof and physically removed all of the nests that I could find. By combining chemical, cultural, and mechanical methods, I came up with a comprehensive response to my pest problem that kept my family safe and prevented future issues. A simple enough example, but I hope it shows how well the principles of integrated pest management apply to problems that are common to homeowners, as well as those of commercial growers and farmers.